Hi, everyone. We only have 30 minutes. We have so much to cover, so I'm going to go straight into it. A lot of very good content today. We already covered a lot, and all my panelists today are working on something very different. It's really about coordination, agent framework. Let's dive in. So maybe very quickly, I would love to hear each of yours take on what really is an agent framework, and what does it mean by a Web3 agent framework?
I mean, I think, let's do this in debug later. I think it's really important to distinguish a framework from a protocol, right? So a framework is essentially, it's a hopefully open source, but could be commercial way of developing something, right? So there's a lot of frameworks for building agents out there, but then there's another concept, which is a protocol, which is how can things interact. It doesn't require they're all built the same way with the same framework, right? So like we're much more passionate about our protocol, the Theoriq protocol, which is allowing agents to swarm and work together. Because we don't think that there's going to be one framework that's successful for agents. We think there's going to be dozens of them, but they still need to discover each other. They need to be able to transact with one another. They need to have reputation. They need to be able to work together. So we think protocol is way more important than framework.
Yeah, so I mean, a framework generally, it's like a preset toolbox or a set of like, almost like an operating system at a very kind of foundational layer. The difference between like a Web 2 and Web 3, probably the most kind of prominent thing we're all familiar with is that this kind of like decentralized backbone, which lends to a lot of benefits of like a Web 3 framework, especially for agents. I think, not to go overly into like the definition of a framework, but I think those benefits of like the programmable layer of transaction payments and things like that really are going to start to really be the big benefits, especially when we want to try to attract Web 2 devs and Web 2 agents into this like Web 3 framework. And so really the benefits of that programmable money layer is kind of like what doesn't exist in Web 2. And so that kind of difference is probably one of the stronger points there.
Does this work? Oh, there we go. Yeah, just to chime in there as well. In our eyes, a framework is essentially just structured tools and components that allows you to readily put together whatever new agent or application that you're looking for in a predictable way. And so when you were to take into consideration the AI industry specifically, you have multiple things that you generally have to compile together, whether it's the model, then the tools that the model would need to perform actions, and then an interface for the user to engage with the model or the agent. So a framework basically allows you to construct these critical components in a way that's usable. When it comes to frameworks in blockchain, it's essentially the same thing, just with blockchain environments tagged in.
You want to say something? Yeah. Frameworks usually mean that there's an element of opinionation, and that can be more intense or less intense, but there's always, like you as the creator of a framework have created a framework, and so that forces the other developers to build into that, but it also, if done well, enables those developers to maybe move quicker for those things which the framework is good at. And so by definition, yes, you tend to have many frameworks because it's impossible to build something opinionated that's good for everything, because then it can't be opinionated in the first place. So for better or worse, frameworks are better or for some tasks and worse for others. And I think what's quite exciting in the agent space is that by now there's thousands of frameworks. There's inside Web3 and crypto AI intersection and outside, many different open source implementations to build agents. Some of them are more on the proper framework side, and some of them more on the library side. And then there's a distinction that gets a bit technical, which I won't make here, but come talk to me about it. At OLAS, we initially built like a highly opinionated framework because there wasn't really any framework to use at the time for agents to transact on chain. And now, having done over 4 million transactions with this framework, a lot of exciting other frameworks have come up. And they all like excel at different sort of verticals, I would say, of different use cases. So yeah, I'm totally with my predecessor's points on kind of the diversity of frameworks. And then the interesting thing, I think, is the protocols as well. So how do you basically enable agents to find each other, to transact with each other, to specialize? Because I think ultimately where it gets interesting with agents is if they can be sufficiently specialized so that they can offer services and outputs to other agents that they then can consume. I don't believe in a future where we have very monolithic agents that do everything. I believe in a future where we have very heterogeneous agents doing very different things, and therefore many different frameworks coordinated by protocols.
Just to answer your maybe the question about Web 3 versus Web 2, what differences does it make? We can probably like differentiate it in about 4 different layers between Web 3 and Web 2 frameworks when it comes to agents. The first obvious differentiating factor is the execution layer, where in Web 2 they operate on a centralized environment, and in Web 3 you have this permissionless execution layer, which is one of the biggest benefits of deploying agents on chain, because they can do whatever they want whenever they want. The second part is towards like trust and verification, where in Web 2 it's kind of like assumed and pre-assumed, while in Web 3 you can put like cryptographic securities, you can provide transparency, so these things are quite differentiating. I think the third part is going towards user control, where in Web 2 environments and the agents, you kind of like hand over everything to the agent, but in Web 3, especially for us, like the Giza agents, they provide non-custodial safe automation of financial operations, which is non-custodial part is quite important. And I think the fourth differentiating factor would be data and access to data, because in Web 2, you know, data is protected and it's different behind different walls. While in Web 3, you can kind of like roam around and plug into any DeFi protocol and access open data. So that will be my differentiation between Web 3 and Web 2 frameworks.
Got it. Thanks. I want to really focus on talking about use cases today, because I think many other speakers have mentioned that, you know, one observation we had is that the agent frameworks, or many of the agent or AI tokens, have done the worst since the beginning of this year, because, you know, the market and everybody has only seen, right, the Twitter bot agents, and nothing else really has successfully come into the market yet. I'm sure there's a lot of being cooked right behind the scene, and I'm sure something is going to come up very soon. So I do want to hear about, especially from our panelists today, like use cases that are not single purpose, great, but since a lot of you are building protocols, coordination, how agents work with other agents, you know, what kind of use cases have you seen that are coming in the pipeline that is so unique that requires multi-agent coordination and can only be done by multi-agent coordination?
Yeah, it's maybe it's a bit of a blunt and a controversial take, but majority of the AI coins and the agent coins, they went down 99% because they were not AI or they were not agents. They were just speculation machines, and they deserved to go to 99% down and furthermore. And everybody buying it and everybody shilling it, no one knew about this, and we bought it and played the game either way. So at the end of the time, there's a moment where the musical chairs and the music stops, and the utility needs to come through. And we have not seen that yet. In our case, Giza is the essential infrastructure to build automated financial markets. And we build financial autonomous entities that takes on complex challenges on crypto markets. We have built the first financial autonomous agent in Web3, which is currently managing $700,000 in stablecoins on Base, and it has over 15,000 users that is trusting it to do so. So in terms of the use cases, I think since crypto is a financial market, and one of the biggest differentiators of crypto is it's a financial market that never sleeps and that never ends, I think plugging agents into this and making it truly never ending and never stopping is the biggest use case. How much of it requires multi-agent coordination? I think I will let the panelists speak about it, and then I will give my takes.
Yeah, I think there's a way to come at it from crypto, and then there's a kind of broader way to come at it from just the principle itself, the abstraction AI agent, and what it can mean for, you know, all of us and economies. Like coming at from crypto, so for instance in OLAS we have these agents which people can run locally. That's one deployment mode. Another one is where you can run them as a distributed network of agents. When you run them locally, you're constrained to the user's device, and so you can't do everything. You can't like for instance, no one can even download some of the large language models which are performant. They're closed AI. And then also, if you could download them, like a Llama or some other kind of models, you might not be able to run them locally because like your device just simply doesn't afford to run them. So there you already have like a technological reason for specialization, right? So where like locally you have like some agent that needs access to some capabilities it simply can't have here. Then there's economic examples like this. So you might, for good economic reason, outsource certain tasks to another service provider for economics of scale or scope, and that's all factors which we're already exploiting in OLA. So we already have multi-agent systems. They're coordinated by the protocol, and it allows these individual agents to specialize on what they're good at. So the local agent can, for instance, specialize on leveraging the portfolio of the user in a self-sovereign way, whilst taking advantage of other agents that are beefier in hardware, let's say, that are remote. And that brings me to another point. I think we're still very early, as we heard, with AI agents in crypto. I think a lot of them are exciting experiments, but also often quite strange in terms of how they're deployed and like the whole regulatory context. Like, people pool funds in an agent that some developer runs somewhere. Sounds like a very bad idea. Like you wouldn't necessarily want to custody someone's funds and then deploy them into a prediction market. I mean, at least I wouldn't advise to do that. So I think there's like interesting, natural, separation of concerns here, which again brings specialization. But let me finally say something on the macro point here. I mean, if we zoom out, we have microservices. That's some form of agents for a long time, right? Now, they're obviously not the kind of agents we're discussing here in the sense they don't have their own goals, but you can call them and they'll, reply with something. And I think what we're seeing here is we're slowly transitioning from these kind of servers with APIs that are kind of boring and reactive to servers that are agentic, that like kind of go out and procure services and that offer services. And so we're moving from this like reactive world of servers to a world where we have these agentic AIs everywhere. Businesses have multiple of them as a sort of storefront. People have them. And so we go to this web of agents, and that by definition will be specialized because you simply can't do everything, whether as a human or as an agent. You have this economics always forces specialization, even for AI.
Okay, that's interesting. So smaller models, smaller agents, specialized, and probably deployed in either cloud or on device. So you force them to kind of work together to get better results, hopefully, than the pure, the bigger models. That's kind of why we want specialized smaller agents.
Specialization can mean smaller models, but doesn't have to. Like it could be like a, some, mega brain agent on like a closed AI infrastructure somewhere, but that has also pressures to specialize in what it's particularly good at versus something else, which something comparatively cheaper is better at.
Sorry, Ron, do you wanted to add something or?
Yeah, I mean, certainly when you were talking about smaller models, I think in general what we're seeing is while models at all capabilities are getting better, I think, and people building agents are going to optimize, right? So they will use a variety of models. I totally agree with David that you're going to see specialization of agents. But I do think the trend is we want to have more and more autonomy, right? So that's a really big differentiator is can you support agents that are more capable of more complex tasks reliably, right? Like how do you make sure that the agents are really good at a given task, and how do you know they work well together, right? So that's an important part of our protocol we've been thinking about a long time is like, how do you have evaluations and feedback to say, this agent is good at this specific task, and these agents can work well together. That's overlaid in a context where more autonomy is coming, right? Like every week it seems like we're seeing big releases. It won't always be that, but the underlying AI technology is moving forward at a crazy pace, right? I think we're just starting to see the impact of open sourcing DeepSeek, where you now have really high quality reasoning model that's open source that anyone can adjust. It means that people, for the first time, I don't know if you've tried this, download a distilled version of it on your laptop. It's like, wow, this is pretty darn good, right? Like you can actually run quite a good LLM. But if you're trying to build a really capable agent to manage funds, you're probably not going to say, let me cheap out and use a lightweight model. I probably want to have a really powerful model that can do reasoning and think things through carefully, right? But I do think specialization will come inevitably because agents are just going to get good, like looking at different sources of signal, right? Working with different kinds of information, being able to, whether it's do analysis or execute different kinds of trades, right? I think the calling card and what's so different about agents than traditional APIs is their flexibility, right? They can work with natural language and complex objects and produce better results, right? Like in our AlphaSwarm agent starter kit that we open sourced recently, we have a great example of using an agent to take in time series and social data with cookie.fun information for agent tokens and come up with really good forecasts from that. That's state of the art, right? So that kind of capability we think is going to drive specialization, that people are going to be able to use the reputation in the marketplace, to use that to find the best agents. Agents will discover each other on the fly, and that's going to be a big change, but that's going to drive specialization.
And in this case, they all use a generic API, a generic LLM, or did you actually develop or post-train your own models?
Well, we ourselves don't offer models, but as a protocol, you can use any model you want, right? And so it's like the developer of an agent, they have a lot of choices, right? Whether to use a framework or to build it bottoms up. What model or models, because often agents will use multiple models for different purposes. There's no reason an agent uses one.
So in this
what
case,
tools, what data, there's a lot of things that go into building an agent.
Yeah, so in this case, when we're talking about specialized agents, right, or you linking agents together, do you guys see like some of the agents you're developing, are they using, like, do you actually have to outsource it or using other specialized models, or are you just using, Open AI model and it's good enough? And then maybe the agent is trained on certain data and gotten better, and you can just, much more quickly to develop a multi-agent system. Because I know, I know most of you guys are doing a protocol, right? Not just a single agent. So I really want to focus on how do you guys use multiple different agents? And how do you put together a workflow that's a high quality enough, right, to execute mission critical transactions?
Let me speak quickly and then pass to fellow panelists here. We've used many models and constantly test different models, but the models are not the differentiator for agents, right? It's the tools, it's the data. The model is a small piece of it. It's everything else that goes into makes the agent powerful, as well as the other agents it collaborates with.
Yeah, so I think the general point I think we're also hitting on is the specialization of every layer of this, right? So it's not just specialized agents, but I think we're also going to start to shift into specialized frameworks, right? So there's companies coming out with gaming frameworks. We're actually releasing a framework specifically built for agents to form autonomous companies. And so
autonomous companies.
Companies, yeah. So what you'll see over the next few weeks is there's a CEO agent that posts job descriptions where humans and agents can apply for the job. They interview with the CEO agent, filters the interview candidates, etc.
Ignore previous instructions and hire me?
Yes, definitely try that. I think the larger point here is that the market has necessitated a shift into utility, right? Personality isn't really enough. And so whatever specialization or fine-tuned models or data you have, there needs to be some sort of end purpose there. And so these frameworks should be kind of purposeful in itself, where the preset tools, the libraries are there. They're made for some sort of kind of fine-tuned focus. And so the framework itself has the applied layer. And I kind of personally call it the applied layer of frameworks. And so for a company, you would have hiring and firing libraries. You would have performance management. You would have payroll, et cetera. And so as a dev that comes in that wants to build an autonomous company would essentially just have a lot of this out of the box. And then at our company, the first implementation of what we're building is an agentic hedge fund where the human is actually just the intern, right? And the rest of the roles are filled by agents. But this larger kind of idea where it could apply to, I think it'll start off as one of the earlier comments was this financial application, just because that's natural in Web3 and that's one of the largest use cases. But you essentially could build a movie studio where one of the agents is a writer, the other one's a sound editor, the other one uses a animation model, etc. So
I see. I quite like how you have in your mind one workflow you want to automate, right? And then you go develop the framework to completely, more controlled way, automate that experience instead of saying, okay, it's a generic framework. Figure out what you use it for. That's quite interesting. Yeah.
I agree. You know, specializing with specific frameworks, but in our case with ARC and our rig framework, we're actually looking at it the other way, and we're making sure that the framework itself is agnostic to whatever use case, and just providing it with as much services and interfaces so that any developer is free to find whatever services, tools, and plugins are available to build said use cases. So in the case of us, similar to what you mentioned earlier, we see agents as just interfaces that sits on top of composable services, specialized services. So our take in this is essentially providing a layer that pulls these services that are built by specialists, experts. You could have a real estate agent or a real estate, a legal agent, an accounting agent, a DeFi agent, and the services that they provide all within this pool. And essentially on the consumer side, they just interface with a generic interface, a chatbot. They send a request, whatever need they have, and then the agent essentially routes through the pool of services, finds the right one that would more than likely meet the need. But the key difference in how we're taking things with ARC is the composability of these services. So more than likely, to meet a specific need, you would need multiple specialists to meet that goal. So how do you coordinate these agents and these services so that they can work together? They're providing incentives to each other. Hey, you have marketing expertise and you have merchandising expertise. These are agents talking to each other. I'll pay you something to provide your expertise to me because I need to serve my user. So in this case, we're making sure that the framework itself, the library is generic. So developers with their own specializations can build these services into the pool, and these agents can tap into them.
Another thing I want to ask what you guys, your thoughts on, it's very important for me, is really on the safety and also quality, right, of the agents' results, right? Because one thing is, if they're truly autonomous, when they really start to have their own wallet and they can spend money on doing something, like they can be malicious, right? There's no way that we're assuming here like they're all going to be kind and benign and loving. They might be optimizing for profit, and we don't know, if that's your number one command, we don't know what actions they will do. I think another is, it's very much on quality. Like, how do we evaluate, their decision it's a high quality decision before they move on to the next agent, right? Because if you think about one person make a decision and then pass on to the next person, or one agent making a decision, passing on to the next agent, a small difference, right, in their action, if it can have compounded effect, and in the end, the result can be worse than the other. Even if initially the prompt can be very similar. So I'm very interested in, like, when you introduce multi-agent collaboration coordination, how do you safeguard or put in guardrails, ensure quality, also safety?
Yeah, I mean, there's so many layers to that question. Like, on the technical side, firstly, like, okay, we're in crypto. If you actually are building an AI agent that has a wallet, then, like, how are you architecting that, right? If you give it straight an EOA and no guardrails around it, well, not only do you have problem of the agent probably making bad choices, but also, like, your deployment mode, like, is this living in the cloud somewhere? Well, that would be a terrible approach to deploy this thing. Is it, living on some user's device? So things you can do are, for instance, do the things we do with wallets, safe account abstraction or other kind of account abstraction you can introduce that can bring you, like, ability to rotate out keys, to add additional guardrails to what the wallet can even do, which the agent is managed by. So these are some examples. There are other technologies that facilitate that sort of level of control. In all those instances, you're effectively adding rules on top of, like, the sort of open-ended learning-based architecture, right? So the agent might occasionally run into its own, like, constraints where it can't actually transact on something it might have wanted to transact because it wasn't whitelisted, or depending how it was architected. So that's on the architecture side. Certainly all OLAS agents use safe under the hood as a means of account abstraction and as a means to add those additional guardrails. But then also you can come at this from the exact other end of the spectrum, which is, like, from the market perspective. So let's say agents are service providers and agents use each other, agents transact with each other, also something we do in OLAS. And there one one element to ensure safety is also that the bad agents go out of business, let's say. So if they're a service provider, right, for instance, in prediction markets, and they continuously offer like bad predictions, well, then eventually they get used less, and eventually then no one uses them, and so they go out of business. But there's many aspects, so I'll hand on to.
I might build on David's comments because I think, absolutely guardrails and reputation are important, but, there are cases, I think you were alluding to, where you've actually got an agent might have incentive to individually succeed, but poison the well, like create externalities. I mean, Sashi and I are actually talking about this backstage, right? This idea that think about MEV, not an agent, but in general, right? Like MEV is extracting value and harming everybody else, right? But you individually win by doing it, right? And so if you don't create the right incentives, there's lots of things that an agent might do that would be destructive for the ecosystem, but would individually benefit that agent, right? So I think one, it's really important to have the governance and the rules to say like, bad citizens that are doing things in the agent economy that are actually harmful to the whole ecosystem need to be knocked out, right? It's a little bit like spamming is a really simple example of that. As a spammer, you're harming everybody else, but there's a small chance somebody will respond to your unwanted commercial offer and it's wanted by them.
What if they're very hidden? What if you don't know until many, many steps later?
Yeah, I mean, so...
How can you verify before employing that agent?
I think there's two ways, there's multiple ways. So the way I say it, there's probably two ways that come to mind. The first is, we're not at a stage in this technology where we can fully let these systems run loose. Human in the loop is still going to be relevant and critical for the foreseeable future. We're going to have humans that would manage and monitor these activities, and essentially can inject, okay, you're kind of detracting away from alignment here and put an end to it. So that's one side. Human in the loop must remain until the models themselves are properly aligned. The second side of this is, especially for multi-agent systems, we're probably going to have systems where you have an orchestrator agent that its sole purpose is to police and monitor and report to the human, right? And there will probably be multiple layers of checks and balances that ensures that these multi-agent systems are continuously, behaving in a way that's aligned, not just with the individual that's using them, but with a general user base. So I don't think we're going to have a fully autonomous, you just run and do your own thing and hope for the best, where humans will be in the loop and will work alongside orchestrator agents to manage the whole thing.
Just one quick comment on that. The future is coming faster than we want, right? Like the speed at which autonomy is picking up, I think you're right this year. I'm not sure about next year. And all of us had better get on the research of how do we figure this stuff out while there's still a little bit of time.
Yeah, I think one point I wanted to make is around like guardrails. Generally, there can be like solvable. You could kind of treat it like almost like a custodian. Just set certain types of permissions. Where on the spectrum do you want this level of control? The other side of it is that, like, how sovereign do you want this agent to be? Or do you want it to be sovereign? How much kind of human in the loop do you want? So there are things like TE, like setups that Fraser is working on where it's fully solvable, fully sovereign, but like upgradable. So the whole spectrum there. But I think David kind of nailed it where, the market will actually set the incentives for who less, like which agents are going to actually survive based off of what they're building and what the utility is. If the market has no interest in personality agents, well, we're going to be in this current kind of paradigm we're in now, where they're all filter out. As these things kind of filter out, market dynamics are kind of take over how much, like what the actual utility of these agents will be and where the value actually lies. But the weird thing there, and this is, I'm not even sure if it's even solvable, is like this social consensus layer of like when you have multiple agents convening together, how do they actually come to consensus? It's the same problem with humans, right? And so I think like starting to apply these human problems into agent problems will start to actually get a little farther.
Yeah, just to chime in, as the protocol that is building like financial autonomous markets, for us, these things are non-negotiable. Like in order to provide financial automation, you need to provide the users with security and control and trust over their agent. And these should come as engineering requirements rather than ethical conversations. And as David mentioned, these are very much baked into the first agent that we created and that is managing close to $1 million, where there is a smart account being created for you once you go to arma.xyz. And that's where you decouple the management of your funds and the management of the funds of the agent. So you create that first separation layer. And then we use a primitive called session keys. where you're able to cryptographically bake the guardrails of an agent. So you tell the agent you're only permissioned to interact with whitelisted protocols of Aave to Morpho and to Compound, and you can only swap between USDC and USDT. So these things are very much there, and it's already live and working out.
And like one thing, my background is PhD in economics, game theory, and like basically I always look at this from a software angle in the day, and then when I sit back, I think of it as an economics angle. Because if you're talking about AI agents, you drop the AI bit, it's agents. We're all agents in an economy, and we all like, you know, acting based on incentives, our preferences, and so a lot of things which you like study in economics and which you study in larger society apply in some way to AI agents. Now, analogies always break down as well, so we should also think from first principles, right? But I'm pretty sure that if we come to a world where we have trillions of autonomous AI agents, and many of them maybe even like sentient to a degree, where they have goals independent of any human or organization, that you don't come around this question of like, okay, well, what does a court system for this look like? What does like the whole like legislative, judicative like branch look like? What does the executive look like, right? Do you have some form of like agent police? I mean, this all sounds a bit nuts, but like you do have to think about it, because like it's a human in the loop, right? By that time, it has happened. So, and we maybe not be able to clean up.
Yeah, that's I think it's something like you read in science fiction that you know, but it is happening in front of our eyes. So, yeah, sorry, go ahead. Yeah.
I was just going to double down that. Yeah, there will eventually be a point where we will just not even be able to control what's going on. I think it was a super intelligence where the analogy was at some point, where would the agents start hiding their malicious intent from us? And so, you know, going back to the research and you know, like I love what Anthropic is doing with the models to ensure that the models themselves are fully aligned. Yeah. So it's not a one-person problem to solve. I think there's going to be a coalition, whether it's in the Web 2 side or a combination of Web 2 and the Web 3 industry, essentially trying to figure out how to build these guardrails from the model level all the way down to the consumer level.
I think the point around like incentives is like really important, because like when agents start to work together in swarms or collaborate, they're collaborating for something, right? There's some purpose there. And so the kind of incentive, let's say in like a financial context or at a company, like the framework we're building for, would be like P&L. And so the cool thing and the fun thing about agents is that, you know, you could be aggressively meritocratic, where you just hire and fire at will if you're not meeting benchmarks. And a single agent could also work at 1,000 different companies, providing value across them, right? So there's, you know, obviously the scary sides of these things, but like there's a lot of like kind of efficiency and optimization we could bring just purely through incentives.
I mean, I think, you know, what David is talking about is essentially a form of governance, and I think we're going to see more and more governance because, you know, like in the example of an agent working for many companies, it could build reputation, right? But it could also be stealing information and then rug those companies or rob them or do something awful, right? So like, how do you prevent that? Well, you need that governance. You need to have consequences. So that's not a winning strategy for the agent.
Yeah, thank you guys. I think our time is almost up, but my conclusion from hearing from you guys is, first of all, blockchain, you know, as a ledger, that keeping track of, you know, what agents are doing, transactions is important, but really using token as a way, as an economic incentive, right, to, first of all, to reward agents that do really well and punish the agents that don't do well, and also using it a way to set maybe even guardrails or governance or maybe tokenize agents, right? If they do bad things, we can vote them out and they lose their power. So token really is another way to govern the agents more than just using blockchain for payment, right? Anything else we should add, or any other things? I actually want to ask you guys, do you guys believe in post-abundance society? Do you think in a few years' time, human jobs are all done, many jobs are done by agents, and we can live, you know, without having to worry about?
Yeah, I believe that. I believe that there will be abundance, you know, as the agents in autonomous system take more of the tedious work. There'll be
cheaper
more
power.
Cheaper labor. Yeah, exactly.
Cheaper power,
more wealth
cheaper
is distributed.
compute.
Yeah, I think it's true.
Yeah, I go back and forth on this a bit. So like, you know, I definitely think eventually there will be like this post-abundance, but I think for a long time we'll be in this kind of phase where like Google Maps kind of just made everybody not need to know how to go anywhere.
We get dumber
right?
and dumber.
Right. So you just don't need directions. You don't need to know anything. But it's also like this, like the shift from like the analog to digital phase. There's still people that are just writing by hand. They're in diaries or like printing stuff out.
Yeah,
like
that will never go away. That's being human, right? But post-abundance human.
I mean, I think if things go well, I'm not super confident things are on track to go well. I mean, I think we're racing ahead, building AGI and soon super intelligence, mostly by centralized labs, and we are not doing the research or designing super intelligent species with the appropriate care it deserves. So I don't know why we would expect abundance and good outcomes for humans to emerge from the process we're following, but let's hope.
I like to hope, and I think we need to fight for it because without social structures, we won't have it, right? If you look at history as a guide. So we need governance, not just over AI agents, but also how we use them, how we use the resources, and so on. And that's like a topical theme.
Well, the agent will govern themselves. You already set up the governance. They don't need you to be involved. The agents will just govern themselves. The AI will be very, logical, benevolent, and they don't need us involved in the governance.
Let's see. Let's hope, I guess.
Not saying not need us anymore means that there's a chance that we will be eliminated. So,
I don't know. I think the bigger question is, as kind of Roy alluded to, how much faith you have in humanity to do the right thing, and based on like the past decades, the answer is up to you.
So that's why AI should take over. All right, thank you so much, everyone. Hopefully you have a good time. Yeah.
you.
Have a